My dear students, today we are going to look at the JK flip-flop. JK flip-flop which we are going to derive from the SR flip-flop. Now why we need to go for deriving a JK flip-flop from SR flip-flop is, in SR flip-flop we have an issue that when both the inputs are 1. What is mean by both the inputs are 1? S stands for set flip-flop. R stands for reset flip-flop. So you want to set and reset at the same time. Set is equal to 1, reset is equal to 1. That is an issue. So either we do a set or we do a reset, but not set reset at the same time. So that set reset condition what we have, which is invalid. Okay. So what we are trying to do is, we will be modifying this circuit SR flip flop into JK, where when both the inputs are 1, output will be complement of present state. Let's suppose in the flip flop 1 is stored. If the inputs are 1 and 1, so this 1 becomes 0. If the inputs are 1 and 1, presently it is 0, it will become 1. That is the idea. So for that, what exactly that we try to do is, in SR flip flop, we will be taking a feedback from the output. Once again, another feedback. Okay. So that feedback will be added to what exactly known as the input along with the S. So the set input is equivalent to J in JK flip flop. R is going to behave like a K. So what exactly that we try to do is, instead of calling S, we will be calling it as J. Instead of R, you will be calling it as K. Okay. So we will be taking out a feedback from Q bar to J Q bar. Okay, as input over here, and from here, okay, I am taking a feedback and giving it to Q. Now this becomes a SR flip flop. Okay, so whatever is there here is maybe enable or clock. If it is enable, it will be a latch. If it is a clock, it will be a flip flop, right? So we can analyze now what exactly the condition of J is equal to 0, K is equal to 0, 0, 0. When you keep 0 and 0, what is the output? Output is 0. Output here is 0. Okay. So both the outputs are 0. Clock is present. Okay. When one of the input to the okay. So what we are going to get is no change. What is that no change? Is, let's suppose Q is at 1 and Q bar is at 0 presently. So 1 are with 0, nor 0, 0, 0, 1. So is there any change? No change. That is, I have assumed 1, presently Q is 1, with 0, 0 being input, there is no change in the output. Once again I am getting the same output as Q as 1, Q bar as 0. Okay. Whatever we are assuming the current value of Q, we are calling it as Qn. Whatever we are getting after assumption, the new value of Qn, we are calling it as Qn plus 1. Qn is called as present state. Qn plus 1 is called next state. Okay, present state, next state. Similarly, what we can do is, we can analyze 0 1, 1 0 case and 1 1 case. What is 0 1 case? K is equals to 1, J is equal to 0. Okay. When clock is present, this is 1 and this is 0. Okay. Is that fine? Let us assume that presently the present state is, say, Q is equals to 1. So this is 1, this is 0, 1 0 is 1, complement of this is 0, this is 0, 1. What exactly? This is 0. Now 0 and 1. What is 0 and 1? ORed 1. 1's complement is 0. So this will become 0. and this is input to this. So once again 0 0, output will be 1. Okay, so q is equal to 0. What we have seen, when j is equals to 0, k is equals to 1, we get a new value of output where q is 0, q bar is 1. Okay, is that fine? Now what is there in this right now? Right now the q is 0, q bar is 1. Similarly, you can verify what exactly happens when I give 1 0. Okay, so to do that, let me erase the few things that we have written so far. Okay, so what I try to do is just erasing whatever we have written so far, then we try to see, okay, the analysis with respect to a new set of data. So what I try to do now is I try to apply, say j is equals to 1, k equal to 0. Now j is equal to 1, k is equal to 0. When clock is equal to 1, when clock is 1, what is going to get? You are going to get output as 1 here. Okay, when k is 0, output you are going to get as 0. Okay, so 1 right now, 1 is output over here, 0 is output over here. Now let us suppose the current value of q is 1. Okay, if current value of q is 1, what exact current value of q is, let's suppose 0. Current value of q is 0, q bar is 1. Q is 0, q bar is 1. Now when this is 0, 1 is coming from over here, 0 and 1. So what exactly the 0, 0, 1 NORed? R is 1, NOR is 0. So this will become 0 and this is being input. Now what we are getting from here is 0, 0, 0, output becomes 1. Okay. So earlier it was at 0, now it has become 1. Earlier it was at 1, now it has become 0. So when j is equals to 1, k is equals to 0, we are getting output as 1. Okay, this is known as state. When 0 1, reset state. Okay, when 0 0, what we have seen is no change. What is mean by no change? If it is set to 0, it will continue to be 0. If it is at 1, it will continue to be at 1. Now let's take the case of when both the inputs are 1. When both the inputs are 1, just we need to analyze, okay, what is going to happen in the circuit, and we are trying to see what exactly the output that we are going to get it, right? So what I try to do is I am erasing whatever is not required. Okay, let us give the inputs 1 and 1. So now both the inputs are 1. Let's say this is 1. Okay, so j is 1, k is 1, clock is 1. Both the outputs are 1. This output will be 1. Okay, so now what is the current value of q? We need to take it into the consideration. Now when we take the current value of q, let's say q is equals to, current value of q is 1 or current value of q is 0. Whatever you take doesn't matter. Either you can proceed with q being 0 at present, or you can proceed with q being 1. So as you wish, let's take the case that q is presently 0. If q is presently 0, this output will be 0 because we are ANDing. So here you are going to get output as, because based on the current value of q, you are going to get the value here. So that value will be 0. Okay, then what exactly we are trying to do is, this feedback is 1, this input is 1, all ones. So you are going to get 1 over here. So we are getting 1 and 0. So the current output what we are getting is purely based on what exactly the feedback that we are considering so far. Okay, now q is 0, this coming in is 1, q is 0. So output will be 0. Okay, and this is 0 and this is also 0, this makes output is equal to 1. So for 1 and 1 case, with present value of 0, q being 0, q bar being 1, we are getting q as 1 and q bar is 0. Similarly, you can analyze this, okay, with respect to q being 1, q bar being 0, j is equal to 1 and k equal to 1. With j is equal to 1, k is equal to 1, we are getting output as complement. Okay, that means if presently the value is 0 with q, q becomes 1. If present value of q is 1, it will become 0. This is how exactly JK flip flop works.